So here I have an image, and I'll run it so you can see my image. That's a picture of a flower, and I haven't done anything to it yet. So the first thing you want to see is I use the function imRead to read in an image, and then you just have the file name. There's a whole bunch of different ways to show your figure, to show your image. You can use image SC, which scales it, or you can use image, or you can use imShow. You can look all those different ones up in MATLAB. Okay. So what this does when you bring the image in is if you look at the size of this image, it's going to be, size of my image. It's going to be 3264 pixels by 4928 pixels, and then it's going to have 3 color planes. So that's for R, G, and B, red, green, and blue. Those are your 3 color planes. So hopefully that won't confuse you too much when you see that there's 3 there. So the first thing you want to do is you want to convert it into grayscale. And so there's a function called RGB to gray. And that converts your red, green, blue image into a grayscale image. So if we do that and then we check the size of it, you'll see that, come up again. Oh boy. Okay. Oh boy. Okay. So you can see that we got rid of those 3 color planes. Now we just have 1 grayscale color plane. So let's comment this out so it doesn't appear every time. So once we have it in grayscale, the next thing we want to do is we want to convert it into a double. So right now the type is, if you look down here, we have a, oh boy, let me clear my variables. Okay, so we have a 8-bit integer right now. So you can see these are uint 8. So what those give us is its values between 0 and 255, which we can't actually compute on. An integer is difficult. You can't do the Fourier transform on it. So you want to convert it to a double. So the other thing we want to do is we also want to reduce the size. So if we just do double of my gray, then it'll convert it to a double. But we also want to reduce the size, so we're just going to do resize. And then you just do a %, so I'm going to do by 15%. That'll get it about to the right size. So imResize, it's called. So imResize resizes your image, and double converts it into a double floating point. So now you want to see it again, maybe. Now it's in grayscale. So we'll just do image SC of my comp, and I'm going to make the color bar gray. Okay. It didn't change the color bar to gray, but now it is a grayscale image. Oh, sorry, it's, oh boy. It's a color map to gray. Okay, so you have a grayscale image. Now we can work with this. So we're going to start doing our computations on this. So the easiest thing you can do is just your Fourier transform, ft equals FFT2, because this is a 2-dimensional Fourier transform of my comp. So MATLAB has now calculated the Fourier transform for us. If you try this with a really big image, it might bog your computer down a lot. So don't forget to resize your image because this is a really big algorithm to run. So maybe you can look at what this looks like. Usually we don't look at this because it's really confusing, but I will show you. So the first thing, we'll just plot the rail. So as you saw before, the Fourier transform is it's complex numbers, so there's a real and imaginary part. So for now, I'm just going to show you the real part. Okay. Yeah, I'm not sure. It doesn't like this. We will come back to this. Or we could copy it from here. Just do that. Okay, so this is how we're going to plot it. Okay, so this is what our Fourier transform looks like, kind of. You can see that, so it's, don't worry too much about these numbers. They don't really mean that much because I had to take the log of it in order for you to see the scales because there's such large differences in scales. So I'm plotting the log of the Fourier transform. So you can see how it's kind of white in the corners, and this is what I was talking about, that symmetry. So these are your low frequency, or your small wave numbers, and then these are all your higher wave numbers. And so what we're going to do now is we're going to multiply this image by a mask. So we'll start with a low pass. And we want to get the size of our image. And then I'm going to do wave numbers up to 10, and then we can play around with that to see how it changes it. So what I'm going to do is start with my mask, and I'm going to set everything equal to 0, and it's just going to be the same size as my image. And then I'm going to take that mask, and I'm going to take from 1 to S in both dimensions, and I'm going to set those equal to 1. Okay, so you can see what our mask looks like to start with. See how it just has this little tiny square in the corner that's 1 and everything else is 0? So the next thing we're going to do is, if you recall, we had to do the symmetries. So we're going to do those, and we're a little low on time, so I'm going to copy and paste those from when I already wrote them. So... Okay, so these two right here, I just basically symmetry imposed those on all 4 of my corners. So you can see that now I have that same little yellow square that are 1s in the 4 corners. So now if I multiply this by my Fourier transform, so I'm going to take ft, which is my Fourier transform here, ft equals FFT2. And I'm going to multiply it by my mask. And then once I do that, I'm going to convert it back into real space. And so to do that, you take the inverse Fourier transform. So we'll say low pass image is going to be the IFFT2 is the inverse fast Fourier transform in 2 dimensions. And we'll do that of our low pass FT. So now you can be amazed to see what happened to our lovely flower. Now it is a big blur. So what would happen if I increase, instead of going 1 to 10, what if I went 1 to 100? Would the image look more blurry or less blurry? So you can see there's a certain point where, you know, you're going to have almost all of the image, right? And you're only using a certain a few of the sine and cosine waves, but you have most of the image there. You're not cutting out that much detail. So now let's do this same thing for the high pass. And to save time, we're just going to copy this whole thing, and we're going to move it down here. And we're going to change it to high pass. And now we'll go back to 10. I'm just going to call it mask instead of mask 1. And now this time we'll have our original array be all ones. And then the corners, we'll make them equal to 0. So now we're keeping everything except the corners. So except those really small wave numbers. We're keeping all the big wave numbers. We'll change all our mask 1s to mask. And then if you'd like to look at it, I'll show you. Whoops. I have another mask 1. Oh, down. Right there. Okay. We'll fix the rest of that in a sec. So this is what that looks like. Now you can see it's inverted. So now we're keeping all of these large wave numbers. And do you remember what this image is going to look like? What kind of filter this is? An outline, yes. So an edge filter. So we'll change this to high pass and high pass. Okay. So if we increase this, oh, you can kind of see it, but let's change it to grayscale. Okay, so can you see my outline? Not quite. Let me see if I can finagle it. Let's see, what did we do here? Nope. All right, so we'll change the C-axis to 0 to 80. Can't see. So I can see a lovely outline on my computer, but I don't think you guys can see it. The resolution of our screen is too small. So you'll have to do it on your own computer so you can see how awesome it looks. Oh, can you see it a little bit?